Alright, let's start this bullshit. Yeah, I'm trying to, I guess, arrange my stuff again. Yeah, it's a lot of stuff. Because I'm supposed to move somewhere, but I don't know where. We'll figure that out later. Yeah. I've arranged my cassettes. Yay! So Brahms is blue. Yes, Brahms is blue. And then it moves like that. Yeah. So anyway, I was looking at that thing because it kind of broke. The rotors broke. Yeah. There's 4 rotors there. There's 5 on that. So that means it's a 9 rotor system. 9 rotor engine, right? Radial, yeah. And that's what spins inside one of those. It's a Homedics air cleaner or air purifier. Yeah. What's the model? I know, I had the box somewhere, yeah. Well, it just doesn't work because, yeah, I need to glue those back on. But then it got me thinking about, like, simple things like plane engines and rotors. Like how many rotors was the right amount, by the Wright brothers, yeah. But still, to take off and all that, yeah. So that's interesting, right, to think about. And then I started playing around with my Oxford mathematical instrument set, yes. Right? It comes with all sorts of things, the set. Yes, it does. So it comes with set squares, 45 and 60, and 180-degree protractor, right? So that's the 180-degree protractor. That's a set square, 45. And that's the 60-30, yeah. And 45, I think, yeah. Or 90, sorry, 90, 60, 30, yeah. So, yeah. They're pretty cool things. And then I started thinking about numbers. I know, but bear with me. So, on the calculator, you have a decimal, which is to the power of 10, right? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. That's the decimal. Then you have hex, which is from 1 to 6. Why is that? It's a good point. So some systems, right, like on a ruler, they work on decimal. So like, the centimeters, yeah, there's 10, and within that there's 10, right, millimeters, yes. But the feet system is I believe it's a hex system, because there's 12 inches on 1 foot, right? And on this ruler it tells you that. So you see, from 0 to 6 gives you finer gradations, and then from 6 to 12, yeah. So a half foot is 6 inches, yeah. And within the inch there are divisions. So that's a half inch, and that's a quarter inch, and that's an 8 inch, and then the 16th as well. So that's just interesting to think about, right? So the feet system is a hex system, and the centimeter system is a decimal system, right? Yeah. And then I started thinking about time. Why? Because when I'm trying to add cassettes, and songs onto my other cassette, yeah, there are minutes and seconds. And they're extremely hard to calculate. You can't just add them on a decimal calculator. No, you cannot. So the point I'm trying to make here is that I have a cassette tape, and it's got songs on it. Yeah, and every song has a certain length in minutes and seconds. So if I want to make a mixtape, I never know how much I have left on the cassettes. And now let's move on to the cassettes. Yes. So this is an Agfa tape, IEC1, ferro color. Why color? Because video games from the 80s. Yeah. But anyway, I digress. See, it says compact cassettes. It's one of the early ones. Yeah. And then we'll move on to this, which is, it's 2 hours. Yes, 120 ferro, super ferrodynamic, and special mechanism under license. But it's only a ferro tape. Agfa Gewehrt, yes, made in Germany. So that's 2 hours. So that means it's got 60 minutes per one side of tape. Right? Yes. Then we'll move on to BSFs. This is one of the early special mechanism, LH Super 90. That's an IEC1 ferric. Then that moves up to Black Label BSF Chrome Dioxide Type 2 IEC2, 60 minutes. Then again, it's a Silver Label 60. And then 90, again, to Chrome Dioxide SM. And then they come up with the Chrome Extra. And that's a Chrome Dioxide, but it's Chrome Extra too. And that's where it gets confusing, right? Then sometime in the 80s, they come up with LHE1 formulation. And at the same time, they have a Chrome Super 2. And yeah, Chrome Super 2. Chrome Extra 2. So that's already kind of confusing, right? Yeah, there's two competing things there. A Chrome Extra and a Chrome Super. And then there is a Chrome Maxima as well that starts to happen within the same time frame. The reason I have these all here, they're all small rectangular window. Right? Yeah. So that's mid-80s. And they tell you all sorts of things here. So that's the Ferro Extra 1, see? And then the Chrome Extra 2. So Chrome Extra 2 is supposed to be better. And then Chrome Maxima is even better. Yeah, that's the Chrome Maxima 2. Then we'll move on to like later 80s. And we have Chrome Extra 2s in 60s. Chrome Super. Yeah. Chrome Super. Chrome Super. And then those, which is Chrome Dioxide Super 2s. See, this one is in silver, and this one is in gold writing, I think. Yeah. So that's a more rectangular or squared off rectangular window. Just the same as the Chrome Super 2s. It's the Chrome Dioxide Super 2, it says. Yeah, so there's a difference. Well, it says IEC2 anyway. Then we get a rounded rectangular window, right? Yeah. And that's the silver writing, Chrome Dioxide Super 2. So that's interesting. So that's later 80s. And then we move to they introduced Ferro Extra 1, and that's a 90. Chrome Extra 2, and that's a 90. And a Chrome Maxima 2, and that's a 90. So finally we have 45 minutes per side, which is one LP. So you can put an entire record onto one side of a cassette. Right? So that's pretty tremendous, because that's the highest quality there is. And it says so on the box. You can't get anything higher than that. No, I don't think so. But those were not bad. Chrome Extras, yeah. And then what's a Ferro Extra? I don't know. It tells you some things about it there. Right? So that's the early 90s, I believe. Yes. So now we finally have all three formulations up to 90. Then these are just these Ferro Extras ones. Yeah. Did you know that Sky used to make their own cassettes? Kind of interesting. Anyway, And that's the late 90s and early 2000s, and that's the end of the tapes. And all we have left is Sound 1, for some reason Ferro Extra 1, and Sound 2, which is the Chrome one. So the Chrome one became Sound 2, right? You can see that. Yeah. And that's a Ferro Extra. It's brown, right? That's like 2000, 2001, something like that, yeah. Sound 1, BSF MTech. So MTech was taken over, or it bought out BSF. That's a sealed Sound 2, and a CD for chrome dioxide, right? Or chrome dioxide. So it's the same initials as CD. So I think the Type 2 was developed to tape the CDs. Chrome dioxide, CD, compact disc, right? Yeah. And that's a Sound, just Sound 1, I guess, and that's a Ferro Extra. Yeah. And then there's a transitional one called Sound 1, and it's just called Sound 1. That's the 90s one, late 90s. You can see by the fonts. BSF Sound 1. Yeah, so that's Sound 1 and that's the ferric. So, what's the best way to explain this? There was one standard at first, right? Type 1. And it could hold 90 minutes. But the signal to noise ratio was crap, right? Everybody knows that. And the hiss was too much. Then they developed Type 2, which was better. But it couldn't hold as much or something. Or it was way too expensive. So I only have one of those. A 90. Most of them were 60. But eventually, by the end, right, chronologically speaking, they were all 90 minutes, right? And they were all chrome, yeah. Well, not all, but they were equally as good, pretty much. Yeah, the super ferric, or ferro extras, or whatever, yeah. And the Sound 2 they're fine. Yeah. So I think that was the nature of the experiment, and they all were either 90 minutes and 60 minutes. And guess what? The tape started pretty much from the 60s with the compact cassette logo, yeah. And they ended in the 90s. Yeah, pretty much. Oh yeah, that's my lesson. I don't know. Someone recorded me when I was a child. But yeah, that's about like 90s. So that's the time span of cassettes visualized. Yeah. So that moves from the 70s. Well, I do have some 60s tapes. Actually, it's a good point. I do have 60s tapes that are like, they're glued together. They don't have any screws in them. So that's crap because you can't fix them. All of these came with screws. Right? So you can open them in case something goes wrong. And guess what? It does. Because it happened to me. Oh, you wouldn't believe it, yeah. A cassette tape fell. And the spindle is inside the cassette, so now I can't play it. See, if that was glued, I wouldn't be able to fix that. But this one comes with a screw, so I can open it. Yeah, and I can fix that and put it back. That's the main point. Like, yeah, the early cassettes, I do have some, I think, in the box of cassettes. Yeah, let's look at these. So these are the Philips ones. These are the OGs, I think 60s and 70s. So you see, that's a Philips tape. Flat screws. And that's also no screws. So that's the original cassettes. They were glued. Because it was cheaper and they didn't know if that will last. Yeah. And then they made the ones with the flat screws, right? Yeah, so you can open them and fix them. And then at some stage they switched from flat screws to cross screws. Yeah. Isn't that cool? Yeah. So those are the early cassettes. So that's the 60s, 70s, then later 70s and 80s, later 80s, 90s, early 90s, later 90s and 2000s pretty much. Like that's the end of the cassettes. Yeah, that's the cassette museum. Also an interesting fact about Vivaldi. He moved to Vienna and died. Yeah. I know, right? And he was only 63, I think, yeah. For some reason, he moved to Vienna and then he died there. Very strange. Yeah. And anyway, where am I going with all of this? So, the systems. The metric system is decimal, right? Because you have 5 fingers, right? You have 10, right? Yeah, if it's 2 hands. The imperial system is hex because of TIE fighters. Look at the TIE fighter wings. The time is also in hex because there's 60 seconds, right, in a minute and all that, and 60 minutes in an hour. But the music is in quarters. Yeah. Like if you look at the digiton or something like that, it's in quarters. 4 and 4, right? Yeah. That's interesting. Why is that? It's because of dinosaurs. Right. So, some dinosaurs had 3 fingers, right, like that, with no opposable thumbs. And eventually they started to pick up things with 2 hands. And what's 2 by 3? It's 6, so it's hex, right? Right. Then eventually I think like maybe those split off into 4, and you can see that on a dinosaur, Protoceratops. The hind legs had 4. So if you have 4, you could probably play music. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? On a piano. And then eventually an opposable tone develops. And you have 5. And what's 2 by 5? It's 10. And then decimal systems come into play. Yeah. So that's the dinosaurs and the fingers. Yeah, and the fingers. Anyway, those are hexagons inside the CD circle. That's the size of the CD. About 12.2, something like that, yeah. The hexagon is an interesting shape. So it's 6-sided, but you can vary the width. So you can have a squashed hexagon or a stretched hexagon, but usually it fits within the circle. Right? Yeah. So it's like a TIE fighter wing, right? Yeah. See? Like some of them are like squashed or, yeah, compressed, and some of them are wider. And to draw a square within the circle, it's actually quite simple. So the reason they give you a protractor, right, in your Oxford set, and that, which is a set square at 45, you're supposed to just find the 45-degree lines in your circle. And then if you measure those, you get those. Yeah, and then you just join them, and you get a square within the circle at 45 degrees. It is a square because I checked it with a diagonal through the center of the circle, and it checks out. So that's a square within the circle. Also, another point. It's 0.1 meters, which is 10 centimeters, which is 100 millimeters. So why call it an inch when that's a foot? Yeah, why not use the same nomenclature? So if a foot is a meter, right, in this example, why not use a centifoot for those? And why not use a millifoot? Yeah, a millifoot for those. Well, because it's in hex, and you can't. It's not decimal. I know it's confusing, but they're different scale lengths. Yeah, that's a hex one, and that's a decimal. And I'm gonna get onto that eventually. Yeah. And what's cool about like Oxford, right? Like the Oxford helix comes from there. Yeah, the set, and also the Oxford Dictionary. And I have a book on book. I have a book on shit. I have a book on stuff. And Oxford used to be called an Oxen Fort. Right? Yeah. It's an Oxen Fort. So I think like towns and stuff like that, they're like... Where did I write that again? Towns are intersections of things, right? Yeah, usually. I wrote that on something. I can't remember where did I write that? A town is a T, right? Yeah. T is for town. Oh, I need to answer those as well. I'm still trying to figure that out. That's a baker's dozen of questions. What chip did Dave Smith use and all that? Logic gates, yeah. English language, I think it comes from Latin, but why? Digital watches, how they work. Numbers, why do they use them? And digital watches, yeah. TCP/IP, transport protocol. History of Apple Inc., Digiton sound engine, Euclidean sequencers, yeah, so Euclidean solids, they probably tie into this somehow. But the T, I don't know where I wrote that. Where did I write that? Oh, I don't know. So a T, right, if you draw that, is an intersection, right, of 2 points, and it's perpendicular usually, so it's like crossroads, right? Oh, I remember where that is. It's here. So T stands for town, or T-junction, or trade, because it's a trade in posts. And sometimes it can be in a Y formation. But Y fort, because it's a cross, really, yeah. And then that's how letter F develops from, like, you know, Old English. Because you build a fort around the town. I think that makes sense.